Hi everyone. In this video, we'll look at some trickier examples involving L'Hopital's rule. To start with, let's remind ourselves of all the various types of indeterminate forms. Anytime you see a limit of any of these forms, it means that more information is required before you can make any conclusion. L'Hopital's rule is one strategy for getting that information, but don't forget that there are also more basic techniques like factoring or rationalizing that can be used also depending on the situation. So don't feel like L'Hopital's rule is a catch-all method for every single example now that you've learned it. And in fact, we've learned that L'Hopital's rule is really a strategy just for dealing with these fractional indeterminate forms, 0 over 0 and infinity over infinity. If the limit takes any other form, then L'Hopital's rule is not directly applicable. In the previous video, we were able to use L'Hopital's rule on some examples that took the form infinity minus infinity, but it required us to convert this into a fractional type first, for instance by using log rules or forming a common denominator. This raises the question of whether similar strategies exist for converting these other indeterminate forms into fractional types, because if we could do that, then we would be able to use L'Hopital's rule in a greater variety of situations. For this video, we'll focus on the 0 times infinity type. Notice that 0 times infinity represents a product where two expressions have been multiplied together. But we know every product can be converted into a quotient or vice versa by introducing a negative exponent. And if we did that, we'd end up with a fraction, which is really what we want if L'Hopital's rule is the method we want to use. So consider this example. As always, the first thing you should do is just try to evaluate this directly. So we let x approach infinity and just see what happens. The expression shown as e to the minus infinity would be approaching 0. An explanation of that can be found in the previous video or by referring to the graph of e to the x. So the result here is infinity times 0, which is one of our indeterminate forms. And for this type, I've just proposed that we convert our product into a quotient by introducing a negative exponent. Actually, the expression we've been given already contains a negative exponent. So if we use it to bring the e to the x down into the denominator, this converts our limit into a fraction, which could allow us to at least potentially apply L'Hopital's rule. But before we apply that rule, we do need to check that the limit is of the appropriate form. So pause and check quickly that this does give us infinity over infinity, which means we do have permission to use L'Hopital's rule. So indicate that with an h as usual. And now we take our derivatives of numerator and denominator respectively. After doing that, when we try to evaluate the limit again by letting x go to infinity, we find that the result is 1 over infinity, which is no longer indeterminate. After all, we know that when we divide 1 by an increasingly large value, the result will become closer and closer to 0, and that completes this example. Let's try another one. Pause and see how far you can get on your own, and when you're ready, we'll look at the answer. So as always, start by trying to evaluate the limit. In this case, if we let x approach 0 from the right, we end up with 0 times negative infinity. To convince yourself of where that negative infinity is coming from, you can refer to the familiar graph of the natural logarithm. And don't let the negative here throw you off. We can still view this as the indeterminate form of type 0 times infinity and use the same strategies that we used in the previous example. So in particular, we'd like to convert our product into a quotient by introducing a negative exponent. Now, since we have two factors here, we actually have a choice to make about which of these should go in our numerator and which one should go in our denominator. The first option is to bring the x into the denominator with a negative exponent. The second option is to bring the ln x into the denominator with a negative exponent. These are both equivalent to the expression we started with, so you could at least try using either one of them. Generally speaking, when you have two options like this, one option will be better than the other, but if you don't know which one is better, just pick one and try it. And if it doesn't work, you can always go back and try the other option. But for now, let's just try this first option and see how it goes. So we want to take the limit of this fraction, but before we can use L'Hopital's rule, we need to check that we have permission. So let's see what this limit evaluates to. To help with that, it might be useful to express x to the minus 1 as 1 over x. And now if we let x go to 0 from the right, this gives us a result of minus infinity over infinity. Pause and think about it if necessary. Now if we pull the negative in front, this result does give permission to use L'Hopital's rule, so let's go ahead and do it. First, take the derivative of the numerator. So in this case, the derivative of ln x is 1 over x. Then take the derivative of the denominator to get minus x to the minus 2. After applying L'Hopital's rule, we normally try evaluating the limit again, but before you do that, I suggest you always look out for obvious simplifications which can be made first. In this case, division by x to the minus 2 can be viewed as multiplication by x squared. And that allows us to cancel an x from the top and bottom before we evaluate our limit, which makes things quite a bit simpler. So now when we go to let x approach 0, we get a nice result of 0, which completes this example. So it turned out this first option was a good choice, and we didn't need to use the second option. But I encourage you to try using the second option on your own, so you can pause and do that, just to start building intuition about how you can tell which option is better in the future. You'll be able to predict that with enough experience, but until you build that experience, just pick one and go for it and backtrack if necessary. So at this stage, we have strategies for dealing with most of the different types of indeterminate forms, but there are still a few others that we need to talk about. So look forward to that in the next video, and I'll see you then.